on this question.
We are made from stars, planets, dust, what?
Right. Yes, you and me are made out of molecules and atoms, what we call ordinary matter. We now know that the universe is only 5% ordinary matter, and it's about 23% dark matter, which we can see its effects in the galaxies around us. Mm-hmm. It gravitates, and it's responsible for holding the galaxies and clumps of galaxies together. But then even more than that, we know the universe is 72% vacuum energy. The empty space is not empty, it's full of energy. This has been the major discoveries in cosmology in the last decade. And what this energy is, we're just beginning to probe. And the Higgs boson is actually a ripple in the vacuum of empty space. Empty space is full of a field called the Higgs field. It comprises a lot of the energy in the vacuum, and it has ripples. It's like ripples on a surface of the sea. That's what the Higgs boson is. So the reason we're so excited about it is the first direct probe of what's really happening in empty space. And empty space turns out to be much more interesting than we ever expected.
I'm sure. So when you get together with Stephen Hawking
yes.
and have a little chat,
yes.
What are you talking about? What are you formulating?
Well,
what did you formulate?
Well, I was very fortunate to work with Stephen and in Cambridge when I was a professor there. And we became very good friends, and he's now visited us twice in the Perimeter Institute. Stephen is one of the most creative minds in physics of the last 50 years. And he has extraordinary insight into quantum theory and space-time. And the questions he's most interested in are the beginning of the universe. So Stephen has a particular scenario about how the universe began. And he's trying to make this more and more precise so that it can be checked against observations. And I have a rival scenario.
Which makes it really interesting.
Which makes it really interesting. And I think the amazing thing is we can absolutely, even though we're exploring different avenues, we can agree, there's an amazing degree of consensus within the field of theoretical physics, what constitutes a good theory and what doesn't. And we will all accept that our theories have limitations, they're not quite there yet, but we agree on the criteria that they should be judged on.
Okay, and you agree to disagree at times?
At times, and it's all up for grabs right now.
So two brain worlds, and it's called a brain world, a B-R-A-N-E world,
right.
collides. Is that yours or his?
That's mine.
That's yours. And
yes.
what does that mean, Professor?
Well, there are two scenarios for the universe, for the beginning of the universe. One was that the bang was the beginning of everything, beginning of time. The other is that it wasn't. There was a universe before the Big Bang, and the Big Bang was a violent event. And in our theory, we picture that as the collision of two objects, which are basically three-dimensional worlds, like the one we experience. But there happen to be two of them, and they're separated by a tiny gap. So if you think of every point in this room, I could travel in three different directions, or I could go in a fourth, which is not visible to us because light doesn't go that way. And the fourth direction is a little gap separating us from another world.
So where does a God, a Jesus, a Buddha fit into all of this?
Well, science works in different ways than faith. I don't think, there's a lovely quote from Georges Lemaitre, who was a Catholic priest, and he is called the father of the hot Big Bang because he discovered he discovered the solutions of Einstein's equations describing the hot Big Bang. Although he was a Catholic priest, he was a very good mathematician.
Right.
And he said science and religion are two different activities, like walking and swimming. You use different muscles, and each has a place, and they're just doing different things.
And as you know so well, no great mind gets stuck in a rut. It can't.
No.
And I don't mean that religion is necessarily a rut. For many, it's solace and all of that. And
yes.
some people are atheists or agnostics. Others
yes.
aren't.
Yes.
Where are you on that side?
I have huge respect for religion, partly because in South Africa, religion, the church played a very positive role in the transition from apartheid to democracy. And the church was all, people like Bishop Tutu and so on, played a very positive role in reconciliation and in encouraging people not to look for revenge. So I'm not dismissive of religion at all. And in many ways I find, I don't belong to any formal religion, but I find that when I discuss with religious people and what they're really doing in their religion is appreciating the universe and its magnificence and the miracle of life, then actually I find we're on the same page.
Sure. What we can learn from nature,
Exactly.
Respect of nature will change the world for
Absolutely.
sure. Back to your roots, again, your parents played a part in the anti-apartheid movement. They were
Yes.
jailed
Yes.
because of their beliefs.
Yes, that's right. So my parents, you know, believe very deeply that there is no difference in the potential of a black person or a white person. We're all the same and we all share this miracle, and to just arbitrarily prevent people from doing things because of the color of their skin was you know, they were strongly against that, dedicated their lives, went to jail for it, and kept believing that things would change. So when I was a child and a teenager, my parents always told me things will change in South Africa. One day we'll have democracy and the color of the skin won't matter anymore. And you know, it was hard to believe them because the government was awfully strong and had a lot of support internationally, the apartheid regime, and it was hard to believe change would come. But it did come, and both my parents were elected to Parliament, and this was a dream come true for us. And I think these are kind of the sources of my great optimism about the future. I see that people can do far more than we usually believe or understand.
And young children can do far more. And if we can tap that curiosity and tap the curiosity of the older ones, and you do that in your post-grad school in Africa.
That's right. So partly at my parents' you know, encouragement, with their encouragement, I started a postgraduate school in Cape Town called the African Institute for Mathematical Sciences, or AIMS. And the idea was very simple. Let's recruit the brightest kids from all over Africa to come to a center. We bring the best teachers in the world. They live in a converted hotel, and they study very intensively mathematical sciences, computing, mathematical modeling, physics, and then they go off into careers where they use those skills in business or government or academia or research or education. And it's been amazingly successful.
I'm sure. The next Einstein could be African.
That's our slogan.
Okay.
We want the next Einstein to be African.
We'll be back with physicist and scholar Neil Turok, the director at the Perimeter Institute for Theoretical Physics in Ontario. He is the 2012 Massey Lecturer.